In this video, we'll discuss the advancement of mathematics through the 18th century. Now, a famous family of that time is the Bernoulli family, who started with the brothers of Jacob and Johann. Now, their work in mathematics began with their close relationship with Leibniz. Thus, they continue to enhance the understandings we have within calculus. Jacob focused not only on calculus and concepts such as polar coordinates and constructing the isochrone, he also did his work in probability. And it's through Jacob that we get the concepts of the Bernoulli distribution and probability. His brother Johann then worked with L'Hopital to construct the first calculus book. And because of the way that it was published, that is why we talk about L'Hopital's rule and not Bernoulli's rule. Just as a reminder, L'Hopital's rule states that if we have the limit of two functions that equal 0 as they approach the same value, if we want to know what that limit is when we divide them, we have to look at the first derivative or the second derivative, depending on what happens, and it can go on looking at the next derivative. This will be true also as if those values are equal to positive or negative infinity. Now, the family then continued for at least 4 generations, providing significant contributions within mathematics realm. And so when you look at the works, you'll see other Bernoullis that were mentioned for their works that helped enhance to where we are today. Now, Leonard Oiler was another famous mathematician that we use much of his works to this day. His father actually studied under Jacob, and that helped him get into the ability to work with Johann. And the Bernoulli family then helped Leonard get a position at St. Petersburg. He then worked there for 14 years, went back to the Prussian Academy for 25 years, and then ended his tenure and his life back at St. Petersburg Academy. Now, what Euler is known for more than anything is his prolific works, where he published well over 500 published works in all sorts of branches of mathematics. Now, as he got older, he lost his eyesight, but his mind, he could see what he was doing so well that he was able to clearly explain and have someone dictate the works so that they could continue to be published until his death. Now, there are many different things Euler has done that we still utilize today. For example, much of the notations we think of started with Leonard Euler. For example, f of x for functions, I for the imaginary number, the summation symbol. He also has things such as e to the I pi plus 1 equals 0 is credited to his works. He also then started what we think of as graph theory and topology when he explored the concept of the bridges of Königsberg and how a path could be traveled so that nowhere was stepped over a bridge more than one time. He also did many works within geometry, such as the formula for the polyhedra as well as the line of a triangle. His works then spread into differential equations and homogeneous functions in many different areas. Because his works were so prolific, he was able to put his stamp on many different areas in math. Now, when Euler left Berlin, Joseph Lagrange took his position there, and he worked to improve the rigor of calculus. And because of his works, he's considered our first true analyst. His works gave us additional notations such as using the f prime and the f double prime and so on and so forth for derivatives, and he did significant works within differential and partial differential equations. He had impacts in number theory as well as group theory. Now, our final mathematician we'll talk about this time was Carl Gauss, who's considered one of the 3 greatest mathematicians of all time, up there with Newton and Archimedes. His works, often we knew more about them after his death than during his life because he did not like to publish, but he was still able to prove many different concepts, such as enhancing the fundamental theorem of algebra. His Gaussian distribution is how we get the normal bell curve and the normal distribution that we use in probability, and he helped enhance the mathematical potential theory used in science. Now, in his other publications, we get modular arithmetic as well as how we operate with matrices, and that's where the idea of Gaussian elimination is provided to him, even though there were other societies such as the ancient Chinese that did use some of those same forms. Also, his works enhanced what we think about with the complex numbers, as he created the complex integer, which is called the Gaussian integer. That allowed him then to develop the domain for the complex numbers and then create the analog for the fundamental theorem of arithmetic. Now, he had many different theorems and understandings that were well beyond his time. Sometimes he would show those proofs and they would be published maybe in his own works posthumously. Other times he would write small notes saying, hey, here's this theorem, but I'm not going to prove it because I don't have the time to do that right now, which then led to some of our major problems that we consider now when we think about what are some of the significant areas we need to still prove in mathematics.